Hi guys, this is the lesson video for Math Module 5, Lesson 25 problem set. So on slide 2, we're going to go ahead and start right away, and we're basically going to be doing the opposite of what we have been doing the past couple days. So the past couple days, we have been going from an improper fraction to a mixed number, and now we're going to be going backwards, going from a mixed number to an improper fraction. So in order to go from a mixed number to an improper fraction, we're going to start out by taking that whole number and converting it to a fraction. And again, guys, we are not messing with the denominator. So if the denominator in the mixed number is 5, that's where we're getting our fifths. So we have to figure out how to write 2 as a fraction in fifths. Well, I know that in order to write one whole as a fraction in fifths, the numerator and denominator would be exactly the same, but I don't want one whole, I want 2. So the easiest way to do that is just to multiply the whole number times our denominator, 2 times 5. Well, I know that 2 times 5 is equal to 10, so that means that 10 fifths is equal to 2. Now, remember, guys, whenever I do these lesson videos, I'm always on the teacher side of ClassKick, which means that I cannot write my answers into the answer boxes. So make sure that you guys are actually typing in your answers here. So now down here in the second part of the equation, to finish figuring out how to go from our mixed number to our improper fraction, we're going to take that 10 fifths and add it to the fraction part of the mixed number. So we're going to add the 10 fifths plus the 4 fifths. And we know that whenever we add our fractions together, if they have the same denominator, we just add the numerator together. So that just means that we do 10 plus 4, which is equal to 14, and that is our new numerator. So we end up with an answer of 14 fifths when we go from our mixed number of 2 and 4 fifths to an improper fraction. And that's basically all we're doing with this lesson. On slide 2, this is kind of written out so you guys can see it step by step. But on slide 3, you'll see it's not written out for you, so you just solve it in whatever way works for you. So let's keep on going with with problem C. So problem C, we have 3 and 5/8, and we already have it set up right here telling us that we have to change 3 wholes to a fraction in eighths. So again, the easiest way to do this really is just to do 3 times 8, and that will tell us what our new numerator is. Well, 8, 16, 24. If I skip count by 8 3 times, I get to 24. So 3 times 8 is equal to 24, and that is our new numerator. So again, I'm just going to rewrite this down here because all we did was take that 3 wholes from our mixed number and change it to a fraction in eighths. And now that we changed the 3 wholes to a fraction in eighths, we can go ahead and add it to the fraction part of the mixed number. So we can do 24 eighths plus 5 eighths. And again, I know that if my fractions have the same exact denominator, then I just kind of ignore it and focus on adding the numerator. So now I can do 24 plus 5, and I know that that is equal to 29. So I am left with 29 eighths as my answer. Oops, sorry, I did not mean to erase that part of my answer. So moving on to part D, we have 4 and 4/10. So same thing, we have to start off by writing 4 wholes as a fraction in tenths. Again, the easiest thing is just to multiply that whole number times that denominator, so 4 times 10. And I know that 4 times 10 is equal to 40. And now that we figured out what that whole number is as a fraction, now down here we're going to add that add that whole number as a fraction plus the fraction part of our mixed number, the 4/10 part. So again, we changed 4 wholes to be 40 tenths, and we're going to add it to the 4/10 from our mixed number. So again, I know that if my denominator is the same in both fractions, then I just leave it alone and focus on the numerators. And now I can do 40 plus 4. Well, I know that that is equal to 44, and that gives me my final answer of 44 tenths. And moving on to part E. So part E, we have 4 and 7/9. So I know my first step in the process is to change that whole number to a fraction in ninths. So again, the easiest way to do that is just to take that whole number and multiply it times our denominator of 9. So 4, 8, 12, 16, 20, 24, 28, 32, 36. Probably should have skip counted by 9s instead to save myself some time, but either way, if you skip count by 4s or skip count by 9s, you should end up at 36. So now 4 wholes turns into 36 ninths. And now I can go ahead and take that 36 ninths and add it to the fraction part of my mixed number. So I'm going to take 36 ninths plus 7 ninths. And again, I know that if I am adding two fractions together, if they have the same denominator, then I don't worry about the denominator, and I just add my numerators together. So now I can do 36 plus 7, and I know that 36 plus 7 is equal to 43 ninths. So again, once we move on to slide 3, you'll see this chart right here, and we're still going to be converting from a mixed number to an improper fraction. The only difference is that now on this chart, it's not really written out for you. Because again, I know a lot of you guys can do this in your head, and if you can do this in your head, that is awesome. You do not have to show me your work here. Here you just have to show me your answer. So I'm going to be showing my work basically by kind of putting dots by the numbers and talking through it. So let's look at part A. We have 2 3/4. So I know that I need to start off by multiplying that whole number 2 times the denominator 4. So 2 times 4 I know is equal to 8. I'm just going to write that right up there. And now that I changed that whole number to a fraction in fourths, I can add it to the 3/4. Now, the other thing here is that I don't even really have to change it to a fraction in fourths. I could have just left it as 8. And then once I figure out that whole number times the denominator, then I add that to the numerator. So then I do 8 plus 3, and I know that 8 plus 3 is equal to 11. And again, I keep my denominator the same. So again, I'm a fan of doing it this way, just kind of doing it in my head or like writing myself little notes because it saves us some work. So let's do the same thing with part B. So part B, we have 2 2/5. So we're going to start off by either converting that whole number to a fraction in fifths, or by just multiplying that whole number times our denominator. 2 times 5 is equal to 10. And then we take that number and we add it to our numerator. 10 plus 2 is equal to 12. And then I just keep my denominator the same. So in all of these, our denominators are going to be the same. We're not changing our denominators at all. So let's look at part C. We have 3 3/6. So again, I could start off by changing that whole number to a fraction in sixths, or I can just multiply that whole number times the denominator. 3 times 6. Well, I know that 3 times 6 is equal to 18. And now I can just add it to that numerator. So then I can do 18 plus 3, which is equal to 21. And again, I'm not messing with the denominator. I keep it the same. So then it just becomes 21/6. Part D, we have 3 3/8. So again, we can start off by multiplying that or changing that numerator into a fraction in eighths, or we can just start off by multiplying that numerator times the denominator. So 3 times 8, which is equal to 24, and then adding it to the numerator. So 24 plus 3, well, that is equal to 27. And once again, I'm not doing anything with the denominator. I am just keeping it the same. Let's move on to part E. We have 3 1/10. So again, I'm just going to do my method here of multiplying the whole number times the denominator. So 3 times 10. Well, I know that 3 times 10 is equal to 30, and I just add 30 to my numerator. So 30 plus 1, well, that is equal to 31/10. Because again, I'm not changing my denominator. I am just keeping it exactly the same. Part F, we have 4 and 3/8. So again, I'm just going to take that whole number and multiply it times the denominator. So 4 times 8. Well, I know that 4 times 8 is equal to 32. And again, I just add that to my numerator. Sorry, I just add 32 to my numerator. So now I have 32 plus 33. Well, I know that 32 plus 33 is equal to 35, so that is my new numerator, and I just keep my denominator the same. Part G, we have 5 and 2/3. So again, I am going to take my whole number and multiply it times my denominator. So 5 times 3, well, 5 times 3 is equal to 15, and now I just add my 15 to that numerator. So 15 plus 2 is equal to 17. So that is my new numerator, and once again, I keep my denominator the same, and I do not change it. H, we have 6 and 1/2, which we need to convert to an improper fraction. So once again, I'm going to take my whole number and multiply it times the denominator, so 6 times 2, which is equal to 12. And then I'm going to add that 12 to my numerator, so 12 plus 1. 12 plus 1 is equal to 13, so that is my new numerator. And once again, I keep my denominator the same. I'm not messing around with it. For part I, I'm going to do it exactly like what we did on slide 2, just so you guys can see the equation if you need to. So remember, on slide 2, we took that whole number and we changed it to a fraction in whatever denominator we're working with. So in this case, we are working with tenths. So I have to change 7 to a fraction in tenths. So once again, we just multiply that whole number times our denominator. So 7 times 10. Well, 7 times 10 is equal to 70. So that gives us 70 tenths. And just like on slide 2, I'm going to add in the fraction part of our mixed number. So I'm going to add in 3 tenths. And our denominators are exactly the same, so I can just go ahead and add my numerators straight across and do 70 plus 3, which is equal to 73 tenths. So this method, how we just did it right here, is exactly what we did on slide 2. It's very, very similar. What I was doing in A, B, C, D, E, F, G, and H was basically just a shortened version of it. And I'll do that again for part I. So the way that we have been doing it on slide 3 is we just take that whole number, multiply it times the denominator, so 7 times 10, which is equal to 70, and then we just add it to our numerator. So 70 plus 3 gives us 73, and we keep our denominator the same. So really, it's basically the same exact method. It's just this one right here, you kind of write things out more formally. The way that I've been doing it on this slide is kind of the more lazy version, but again, guys, with math, I'm a fan of making things as simple as possible, because I think if things get made too complicated, then it's way too easy to make mistakes. So on slides 4 and 5, you guys are just going to be converting from mixed numbers to improper fractions. So again, I don't need you guys to show me your work. You definitely can if you want to, and I always appreciate seeing your work, but I really just need to see that improper fraction. And same thing on slide 3, you're converting from a mixed number to an improper fraction. So as always, guys, feel free to watch this video as many times as you need to. If you watch the video on slide 1, it will probably be pretty similar. It might be slightly different though. If you guys get stuck, just leave me a private comment asking for help, and I will see you all later. Bye, guys.